Okay, welcome to the final lesson in our rationals. Today we're going to look at solving rational equations. So we've done expressions all the way through, and now we're going to actually look at having an equation, which is nice because when we can actually solve for what x is. With an expression, all we can do is simplify, but with an equation, we can solve. So it's always been good to know that terminology, that math vocabulary, right? So here we have an example. One, in A, all it is an expression, so we can only simplify this. They have a very similar looking one in example B, but they have it to equal 1, which means because it's an equation, now we can solve it. So let's take a look at how these are similar and how these are different. So let's go back to just a quick review here of an expression, and we can simplify, right? We're looking for that lowest common denominator. We are achieving a lowest common denominator, and then we can bring our two terms together. So here I have two terms, one with an x minus 1, one with an x plus 1. So I will need to sit there and say, okay, I'll have my 3 over x minus 1 is going to need that x plus 1 over x plus 1, right? Value of 1, I'm not changing the value, I'm just giving it a common denominator. And I'm going to subtract on this one, I have the 2 over x plus 1. And to get that common denominator, I'm going to multiply this by x minus 1 over x minus 1. So now I can simplify this. So this becomes 3 times x plus 1 over minus 2 times x minus 1 over. So there we go. I just got to remember I'm subtracting everything here. So if I was to reunite this all as one term, I'm taking the 3x plus 1, or plus 3, sorry, minus 2x minus 2, and again that's a term that we're subtracting everything out, so the brackets are going to help me keep that all in place. So of course then we go down below, so 3x plus 3 minus 2x plus 2. I'm running out of room in a hurry here, so 3x minus 2x is going to equal 3x plus 5 over x minus 1 times x plus 1. So that would be my simplified answer. It doesn't look very simplified, but yes, we had two terms, we just combined them into one term. Yes, there would be some NPVs, but as this is review, I'm just going to brush through that real quickly. So we can get to the real meat and potatoes of what we're going to be doing in this lesson, and that's going to be taking a very similar equation and solving it. And what we're going to do here is, now that we can solve it, is this is where that finding of the lowest common denominator comes in handy. I'm going to show you something slightly less writing than what's in the example, but basically the same thing here. So we already had the 3 over x minus 1 minus 2 over x plus 1 equals 1. There is no denominator there, or denominator 1, whichever you prefer to say. So we already know what the LCD is, right? It's the same as what was over here, x minus 1 times x plus 1. And the first thing we can do with solving an equation is find that lowest common denominator and multiply it through everything. What that does is it allows us to get rid of all denominators, and then we have a question that we can solve in a very more linear sort of format. So I know my LCD is x minus 1 over x plus 1. So I'm going to write this slightly different here. I'm going to put the entire equation in brackets because I'm going to say I want to multiply the entire thing by x minus 1, x plus 1. And that saves me a little bit of writing. Now when I'm writing this through, so I want to take this 3 times, so 3 times x minus 1 times x plus 1 over x minus 1 minus, again, I'm doing the same thing here because this has got to get right, 3 times x minus 1, x plus 1, the 2 times x minus 1 times x plus 1, and the 1 times x minus 1, x plus 1. And I can show each of those. That's going to equal 1 times, which is, I'm not going to write the 1. The 1 just becomes redundant at that point. So there we go, I have it written out, and it looks big and nasty, but the advantage of the equation is it only looks nasty for that one step. Now we can start crossing things out and make it look easier, right? So x minus 1, that's crosses now. An x plus 1 and an x plus 1, and these ones have nothing. So I'm getting rid of denominators already. That's great. So this becomes 3 times x plus 1, or 3x plus 3, minus, now don't forget this is not a minus, I'm going to put this whole thing in brackets just to keep it together. It's 2 times x minus 1, which is 2x minus 2, and then my x minus 1 times x plus 1, we should know, is x squared minus 1. So now I got everything, and now I can start solving for x. So 3x plus 3 minus 2x plus 2 equals x squared minus 1. Collect my like terms. 3x subtract 2x. X, 3 and 2, plus 5 equals x squared minus 1. And now we're going back again to what were we doing with our quadratics. We want to solve for what x is. Let's make the entire equation equal to 0, and then we can solve for x using our quadratics with that. So this is going to become 0, is x squared. I'm going to move that x over here, becomes minus x. Subtract the 5, minus 6. So 0 equals. Factor this. We're looking at a minus 3 and a plus 2. So now we know that x is going to equal 3 and negative 2. And there we go. The only thing is, of course, we will have NPV, some non-permissible values. I didn't include it in the first example. I will include it from this point on. So we know our non-permissible values, of course, would be the plus or minus 1, and that's just in the future what we'll look at. That is how we solve a rational equation. So we take what we learned in adding and subtracting with our common denominators, and we apply it to make our lives easier, and we can come up with solutions. And the advantage is, if you ever have that question, am I right? Take the 3, take the negative 2, plug them into your original equations, and you should see that they do in fact equal out. So I will reset, we'll move on to example 2, and we will continue this lesson. Okay, so taking a look at example 2, in this one I'm only going to work through example 2a. 2b is pretty straightforward, and it's also pretty similar to what we'll look at in 3. So if you do need help with 2b going forward, let me know. I can add in a separate video later to go through it. But again, so 2a is going to be just a little bit of a repeat, just another look at the same thing we did in the previous one, only this time we will add in the NPVs at the appropriate time, which is going to be before we start canceling out denominators and canceling out factors. We should probably do our NPVs before we start pulling things out of our equation. As normal here, we have an equation, so we follow our rules, right? I can't simplify unless I can't start looking for an LCD unless I have everything simplified, factored first, right? So I have a 2 over x squared minus 1. That, of course, can be factored. That's enough for me to say I have to do this entire thing to make sure. So this is 2 over x plus 1, x minus 1. Minus 1 can stay. And 1 over x minus 1, of course, is simplified as far as it goes. Now I got to look for what are my, excuse me, lowest common denominators. So I'm looking here, I have an x plus 1 and an x minus 1. Here, just a 1, and here the x minus 1. So my lowest common denominator will be one that has both the x plus 1 and the x minus 1 in it. I can remove all denominators just by multiplying the entire equation by that LCD. So the entire thing of x plus 1 times x minus 1. Now I'm just going to do my FOIL, go through all of this. So this will become 2 times x plus 1 minus 1 times x plus 1. So again, the 1 becomes redundant. I can just leave it as such. Don't forget it's a subtraction, minus. And this is going to equal 1. Again, the x plus 1, x minus 1. That's all over x minus 1. So when we get into an equation like this, I would like to start crossing things off now. I'm ready to start crossing factors out, but I can't unless I have my NPVs figured out first. So just on a side note, I'll put a little dot here, NPVs. And we can jump to these really quick now. This is x minus 1 plus 1. So x cannot equal plus or minus 1. So that's something that's really easy, straightforward. I could add that at the end of my answer. Now, because I removed that, I can start looking at pulling factors out. So the x plus 1's gone. X minus 1's gone. Left alone. X minus 1's gone. Now I can rewrite this in a much more simplified form, which is just going to be 2 minus. I know I'm going to have to factor these to add and subtract, so I'm going to jump into this now, right? So x squared minus 1 is going to equal x plus 1. I am going to do the subtraction, so 2 minus x squared plus 1 equals x plus 1. Again, my little thing gets in the way here. So 2 minus x squared plus 1 equals x plus 1. I need to say I got this in quadratics and I want to solve for x. So because it's in quadratics, I'll have to make it equal 0. So 0 equals, so the x squared comes over. I have an x there and that's it. So plus x. And I have 3 on this side I have to subtract, so minus 2. So 0 is x squared plus x minus 2. That's some real simple factoring. X plus, x plus 2 times x minus 1. So therefore my answer is going to equal, I ran out of room again here. So x is going to equal negative 2 and 1. I chalk up, take a look at my NPVs. Oh, wait a minute, x can't equal plus or minus 1. Therefore, so x equals negative 2. And that is my final answer, as the 1 would be an extraneous root. So there we go, that is example 2A. 2B is a little straightforward, so just give it a go through. Again, if you're stuck, let me know. And I will set up and we'll take a quick look at example 3, and we'll look at how we can solve that one with graphing as well to check our work. Okay, so example 3, again, should be fairly straightforward. I'm going to go through this relatively quick, I hope. So 2 over x plus 1 over 2 equals 3 over x. It's already factored as low as it goes. Lowest common denominator, 2, there's an x, so 2x. Multiply the entire equation by 2x. Becomes 2 times x over x plus 2x over 2 equals 3 times 2 times x over x. I just wrote it this way so it was easier to find some of these factors. Again, so like the x's cancel off. I should do my NPVs first. I will do that next. 2's cancel. X's cancel. Before I start canceling my NPVs, in this case it was just that x could not equal 0. So that one was fairly straightforward. So this becomes 2 times 2 is 4 plus x equals 3 times 2 is 6. So x is going to equal 2. That does work with our NPVs. There we go. So that's our answer. Straightforward, simple question there. The one thing we were looking at this question it talks about is how do you graph this? And I would like to say one thing about how they graph is just fine, but there's another way we could graph it as well, and that's the way actually I like to do it, which is why I'm showing this. So, graphing this, so option A, of course, is going to be the way they said. Okay, we had 2 over x plus 1 over 2 equals 3 over x. They said turn this equation into a 0, graph it, and look for the zeros. So there we go. So if I leave this as 0, I have 3 over x, subtract 2 over x, subtract 1/2. So I just moved everything to the right side. I can simplify, common denominator there. So 0 equals 1 over x minus 1/2. So that's option A, right? You could graph 1 over x minus 1/2, and you look for when is that equation equal to 0, or sorry, more specifically, when is y equal to 0, because we're going to remove this and put in y equals. So when does y equal 0? That's one way of checking your work graphically. The way I like to do this one myself is option B, because most of our graphing calculators have the option to graph multiple lines over on the same graph. So I'm going to keep left side and right side. So I'm going to graph my left side as y1 would be 2 over x plus 1 over 2. I'm going to graph my right side as y2, which is equal to 3 over x. And I graph that line, and then between these two I look for the intersection. And where the two intersect, of course, will give me which x value that would occur at. And I like doing it this way just because of the same way when we were doing our checks, right? When we kept our left side, we kept our right side. This does the same thing. It keeps the equation in original format. There's no simple algebra mistakes. What happens if I've added or subtracted the 2x here, but I've forgotten added the 1/2? I'm just trying to eliminate extra steps. So again, try it with your graphing calculator. If you have any issues with that, let me know. And again, I can show a quick video where I enter these into the graphing calculator to check what our work is. So we have 2 examples to go. That's example 4 and 5, and they are very similar questions. So what I'm going to do is then I might work through 1, I might work through 2. I know I should have this planned already, but because they're very similar, I'll work through of them and we'll see how it goes. So just reset and go. Okay, so example 4 is a word problem, and these are ones that it's normal to have an issue with. If you are struggling, do the best you can. I get it. I used to struggle with these too, and I still run into a lot of these word problems that do cause issues. It happens. But it's amazing how much of it can be worked out if you just start writing stuff down. Draw a picture of the situation. Include any kind of knowledge that you think you recognize, that you know that would pertain to you. Write it down, jot it down so you can see it. The worst thing you could do is just stare at it blankly and say, I don't get this. Right? I'm going to read the question out here. Sophie can canoe 5 kilometers in the same time as it takes Skylar to cover 30 kilometers in his motorboat. If Skylar's boat travels 40 kilometers an hour faster than Sophie's canoe, how fast is Sophie canoeing? Round to the nearest 10th. Okay. So here we go. They're talking about the speed and the rate. They're talking about distances. They're talking about time. So right away, I'm also a physics teacher, so I go like, that's the velocity formula. The one they use in here is they're going to say that distance, rate, and time, right? So standard formula. So your rate is equal to your distance over your time. So that's your standard form. So then I'm just going to start writing down. I know I should have variables, and I'm comparing 2 people, so I can start making a list. Sophie. What is Sophie's D, R, and T, distance, rate, and time? Skylar is my other one, so I'm going to put Skylar's name over here. Which is, again, distance, rate, time. So now I can start piecing this information. Sophie can canoe 5 kilometers. It gave me a distance. 5 kilometers. In the same time, it takes Skylar to cover. They're saying in the same time. My T's are going to be equal. That's going to be a clue, right? They're telling me these are the same, so I can make these equal to each other. So that is very important. In the same time, it takes Skylar to cover 30 kilometers in his motorboat. So his distance is going to be 30 kilometers. If Skylar's boat travels 40 kilometers an hour faster than Sophie's canoe. So Sophie's canoe, how fast is Sophie canoeing? So again, Sophie's the unknown. They're saying how fast is Sophie? She's my X in this situation. How fast is Skylar going? Whatever Sophie's doing, he's going 40 kilometers an hour faster. So it becomes X plus 40. And as it turns out, that seems to be enough information to make things work, where the times are equal. So if I put both of these in context of time, So if I rearrange this formula and say, okay, well, time is the distance over the rate, Sophie's distance over rate, so d of Sophie, so the distance of Sophie over the rate of Sophie is going to equal a time, which is also going to equal the distance that Skylar goes and the rate that Skylar goes. So this is equal to this is equal to this. I can eliminate this middle step here, and these can just be equal to each other. So Sophie's distance over Sophie's rate equals Skylar's distance over Skylar's rate. We have some values we can plug in here. Yes, they're going to turn out to be rational, but luckily that's what we're doing. So Sophie's distance, so 5 over Sophie's rate is x, is equal to Skylar's different distance is 30 over x plus 40. This is now set up as a rational equation, and I can solve it the same as I solved any previous rational equation. So I can take this and then say, what's my lowest common denominator? An x and an x plus 40. That's going to be it. So times x plus 40. Multiply that through. 5 times x plus 40 over x equals 30 times x plus 40 over x plus 40. I can start canceling things out, but I should probably look for some NPVs here first. So NPVs. So x cannot equal 0 or negative 40. There we go. Now I just got to solve this as per usual. So the x's cancel. We'll use a different color here, so that cancels. The x plus 40s cancel. And there's not even a quadratic. This becomes a straight up x to the first power solving, right? 5 times x plus 40 is going to be 5x plus 200. The 30x is left, so 30x. I'm going to subtract 5x from both sides, so 200 equals 25x. Solve this through, and I'm running out of room just at the right time. So 200 divided by 25, so x equals 8. And there is my final answer. X equals 8. Again, it's referring to a rate, which is going to be kilometers per hour. Of course, this is a word problem. I will give a final statement. It was asking how fast is Sophie canoeing? So Sophie is canoeing at 8 kilometers per hour. Again, pay attention to the question, because what if it asked how fast is Skylar canoeing? Well, what can we say for an answer? X plus 40. So Skylar is motorboating at 48 kilometers per hour. So there we go. Again, take your time, work your way through it. I have decided I am going to take a look at example 5. If you think you got it, great, move on and go to the assignment, the final assignment in rationals. If you want another example of this, I'm going to work through example 5, but I'm going to do it ever so slightly different than they did it in your answer key. Want to find out what the difference was? Stay tuned, and we'll set that up next. So example 5, very similar question. Mark can ride his bicycle 2 kilometers an hour faster than Tamara. They begin at the same spot and at the same time, but they travel in opposite directions. After traveling for the same length of time, again, we have the same length of time right away. That's my key. Boom. Time is the same. Convert this to time equals distance over rate. And we're going to compare their distances versus their rates to each other. So the same question, set it up. So after traveling for the same length of time, they stop and realize that Mark has traveled 27 kilometers. Mark, 27. And Tamara has traveled 21. How fast was Mark traveling? The way they word this is Mark can ride his bicycle 2 kilometers an hour faster. And the way they set it up is Mark gets the x plus 2. I like to leave my questions in the format that they're asked me. So if you were to read this question and try it on your own, I'm thinking you're going to get it the same way I do, right? Because it's asking how fast is Mark traveling. So my go-to would automatically be to give Mark the x. And if Mark is going 2 kilometers an hour faster than Tamara, then Tamara would be going Mark's speed less 2. Where they gave Mark the x plus 2, they gave Tamara the x. I'm solving for x, I'm solving for Mark, so this will take me right to my final answer. Otherwise, the math works out the exact same. So we're going to say Mark's distance over rate is going to be equal to Tamara's distance over rate. So 27 over x is going to equal 21 over x minus 2. Similar setup with that. Common denominator, x times x minus 2. So 27 times x minus 2 over x equals 21 times x minus 2 over x minus 2. Leaves me a chance now. I want to cancel things off. So NPVs cannot equal 0 or 2. And I can just start canceling off, right? So I have x and x minus 2 and x minus 2. Again, you look at it, and there's not even any quadratics in this one. That should make it a little easier. 27 times x is 27x minus 54. 21 times x equals 21x. Subtract 21 from x from both sides. 6x equals 54. So x equals 9. So there's my final answer. How fast was Mark traveling? Mark was traveling at 9 kilometers per hour. Again, the only difference was, of course, they had it set up where they solved for Tamara going at 7 kilometers an hour, and then they added 2 to get Mark's 9. I just set it up slightly differently. So again, don't feel that because your method of answering doesn't match the teacher, because it doesn't match the book, just because it doesn't match what's out there at that time, doesn't mean you're wrong. There's lots of ways we can work through math problems, and that's half the fun of math is trying to find your own way for solving your own problems. As long as you show your work so everyone can follow what you did, everything comes up great. That's it for our rationals. Congratulations on making it this far through. And we're going to move on, I believe, to trigonometry next, but be prepared for the next modules to come to you online. Thank you.